Do you remember 1995? For us, it was the year of BBSs and rollerblades. But unbeknownst to almost everyone at the time, something huge was happening in the background. 1995 was also the year of the Virtual LAN. And here's the thing, VLANs have been around for decades now. They're used in corporate offices, data centers, IP phones, and they're even useful in home networks for isolating things like IoT devices. But what exactly is a virtual LAN? What did it mean back then, and where did they come from? And that's what we want to find out. So we're going to go on a 30-year journey to figure out their origins so we can finally unravel the mystery of the VLAN. All right, Wikipedia, VLAN. W. David Synkowski. Dave Synkowski was a pioneer in early Ethernet and studied under David Farber, who is called the grandfather of the Internet. Synkowski worked at Bellcore, the research and development arm of Bell Labs. There, he worked on voice over Ethernet technology, and according to this memoir of his published in 2002, he actually independently invented the learning bridge about a year after Mark Kempf had done it at Digital Equipment Corporation. And working for Bellcore, the problem he was trying to solve was how to scale Ethernet so it could be used for telephone service. The US telephone network at that time had the capacity to connect around 100 million phones. In this paper, he asked, could we build an actual phone system on top of Ethernet? There were a lot of questions in those days about the suitability of Ethernet in particular, and packet networks in general for carrying voice. After all, everyone knew that voice was inherently circuit-based. And one of the solutions that he proposed, along with his colleague Chase Cotton, was the concept of a multi-tree bridge. This refers back to a document called Extended Bridge Algorithms for Large Networks, published in 1988. And if you read through this, it's dense. At first glance, it has little relation to what a modern network is. But the key technique described here was to add an identifier to each packet to effectively segment Ethernet traffic that shares the same physical infrastructure, which sounds exactly like what a modern VLAN is. Take this switch, for example. It has 52 ports that by default are all bridged, or in other words, they all share what's called the same broadcast domain. When you connect a PC's NIC to a switch like this, after negotiating the link speed, it will first send a DHCP discover request, as it's looking for a DHCP server to assign it an IP address. And it sends this request to what's called the broadcast MAC address, which is all double Fs. The switch sees this broadcast MAC and floods the DHCP discover packet to all ports on the switch, because they're all in the same broadcast domain. And broadcast traffic doesn't just end with DHCP. ARP is used to maintain IP address to Ethernet MAC mappings, and other applications send broadcast traffic to discover what's on the network. On a home local area network, this is no big deal, but expand this behavior out to hundreds, or in the case of Synkowski's application, millions of connected devices, and broadcast traffic becomes a serious issue. Every ARP request, every device discovery, every broadcast hits every single device on the network. But this is where the virtual LAN comes in. This is an Ethernet frame, and within it is the IP packet along with some headers. By adding an ID tag to the frame header, the traffic can be split into different virtual networks. This splits up or segments the broadcast domain, effectively creating entirely separate networks all within the same physical switch. These tags are defined and managed by the switch and are typically port-based. So on this HP ProCurve switch, we can set up two VLANs, one for ports 1 through 12 that we'll call red, and another for ports 13 through 24 that we'll call green. And we'll remove them from the default VLAN. So now traffic on ports 1 through 12 is completely isolated from all of the other ports, even though they are all on the same switch. And the same goes for ports 13 through 24. I've got DHCP requests originating from this mini PC. Right now, both my laptop and the mini PC are connected to the red VLAN, so all ports on the red VLAN receive that traffic. But if I switch the laptop over to the green VLAN, we can no longer see the DHCP request from the mini PC. So just like that, VLANs allowed us to segment the broadcast domain and create separate virtual networks all within the same physical device. And while this layer 2 switch can't do it, layer 3 switches and routers provide the ability to forward certain traffic between VLANs. So I could let the green VLAN send traffic to the red VLAN, but not vice versa, for instance. And so this means VLANs are also incredibly useful for security, providing the ability to isolate different types of devices, like separating guest Wi-Fi from corporate systems, or preventing IoT devices from phoning home. And VLANs don't have to be port-based. They can be assigned by MAC address, giving even more flexibility in how networks can be segmented. And VLANs, as we know them today, were first standardized in 1998 by the IEEE 802.1q standard, but have grown to include a ton of different features over the years. So Synkowski may have come up with the general idea of what a VLAN is, but we wanted to know what was the first device to actually implement them. And this is where it gets interesting. Searching around for more clues, we found a Wikipedia entry for Kalpana, which, if you don't know, Kalpana released the first multi-port Ethernet switch in 1990. But it also says here that they invented the virtual LAN concept, which we already know is not true. But maybe they had the first device. But then searching some more, we found a reference to Ungerman Bass claiming that they had the first VLAN. So it's not really clear, to say the least. We figured that searching around IEEE documents might give us a hint of where to look next. Mark found a stash of IEEE 802 documents from 1995, and searching through them revealed several that were related to VLAN development. One of the participants in the 802.1 working group was John Wakerly from a company called Alantec. He gave a presentation to the working group in 1995 about VLAN technology, and crucially, we found this bullet point here, where he mentions the Alantec multi-LAN switch supporting something called bridge groups back in 1990. Neither of us had heard of Alantec, but they were an early pioneer in the Ethernet switching market.
The Power Hub brings intelligent switching to conventional local area networks.
Based out of Fremont, California, their first product was called the Smart Bridge, and it was a 2-port Ethernet bridge on an ISA card. The product that Wakerly cited, the multi-LAN switch, was released in 1989, and it was actually based on a modified IBM PC-AT with several of these Smart Bridge cards installed. After some brief searching, we were able to get in touch with John, and he confirmed that bridge groups were one of the earliest implementations of virtual LANs.
And we didn't call it a VLAN, but that's what it really is.
John got us in touch with Mano Morty. He's actually an award-winning musical composer for Indian films, but prior to that, his start in networking was at Bell Northern Research.
And basically BNR used to develop all the products that were manufactured by Northern Telecom and deployed by Bell Canada, data switches and PBXs and so on. Somebody approached me to start Alantec because I was the only software guy they had. And I was the only software guy for a long time. So the first Alantec, when we started in 88, we developed something called the Smart Bridge, and then later on something called the MLS or multi-LAN switch. And it never really, it was not able to stay up for a long time at any customer side. So it never really took off. So then the investors were not happy with what was going on. So they said, okay, we're going to scrap this product. Let's develop a new one. So that's when we got John came in and they got a new CEO. So John was the CTO and I used to work for him. I was the only software guy at that time. And we developed the Power Hub. Okay, and that's where everything really started, with the Power Hub.
It was a unique device for the time, featuring 12 hubs, each with 3 ports that could be bridged. It used dual RISC processors with a shared memory architecture, enabling them to implement the bridge group concept completely in software without losing any performance.
We decided to do the router on the Power Hub. We said we're going to build, not just a bridge, but also a router in the same product. So that's when I studied the Cisco routers, because they were pretty much the only router at that time. I mean, there were other things, smaller players, but the Cisco was a predominant one. But in our case, our advantage was that we had the router and the switch running in the same box, and we were software driven. We did not have anything committed into ICs. So I said, okay, let's do this concept of port groups, which was really like VLANs without the tagging. But the port group would span. You could have any number of ports you wanted in the port group, and that could be a subnet. Okay, and then you could go between subnets, or you could route between subnets that are somewhere else, going over another WAN link.
They actually patented this technology in 1993, calling them network groups in the patent. But even this implementation was very different from VLANs today.
That was new. That was the first time, because nobody else had it.
And the Power Hub was ahead of its time. It handled Ethernet switching and routing IP traffic between networks. This feature combination was later marketed as Layer 3 switching and multi-layer switching. But most importantly for us, I think we can pretty confidently say now that Alantec was the first with virtual LAN capability in an Ethernet device, even though their implementation of it was pretty unique. And so we actually found this Datamation article from 1993, which seems to confirm that as well. So that's one mystery down, but now we need to figure out what happened after that. Searching on Google Books, we found a huge increase in the mentions of virtual LANs around 1993. We found articles about other vendors like Ungerman Bass, who had created their own VLAN solution called a Virtual Network Architecture, or VNA, which was implemented in their Dragon Switch product. Why isn't anyone naming their products like this anymore? And Kalpana had their own version as well around the same time. And VLANs were a huge deal back then. This is an article stating that moving users around on their LAN could cost a network administrator $80,000 a month, which in 2025 is nearly 175 grand. And this was apparently a big application for VLANs at the time. If an employee in an office moved to a different department, for example, but kept their same physical office, they might need access to different resources. Without VLANs, this would require potentially expensive rewiring to move their network access to the right infrastructure. But with VLANs, the port they were connected to could simply be reassigned to a different VLAN, giving them the needed access. That's not to say everyone was gung-ho about it, with one article stating some admins were, quote, squeamish about getting involved. Ugh. Much of the talk about virtual LANs in the mid-1990s went hand in hand with ATM. ATM was seen as the future of networking by many around this time, and the ability to segment traffic was a key part of how it was architected. And VLANs weren't confined to just ATM and Ethernet. They were implemented on FDDI and even Token Ring. And as you can imagine, all of these emerging solutions created an interoperability nightmare. While these different implementations would work great if you only used gear from a single manufacturer, there was no way for VLANs to operate across different platforms, since the implementations from each manufacturer were unique. So given this, there was a clear need and a ripe opportunity for a standard to emerge. We continued our IEEE document hunt and eventually found Martin McNeilis from Cisco, who had delivered this presentation boldly titled 1995, the Year of the Virtual LAN.
Obviously, life for me started back in Scotland. That's why 30 years in Silicon Valley, give or take, hasn't put a dent in the accent. So for this recording, guys, you may want to add some subtitle capability. I was working in switching in Switzerland, and the company over there bought a company in Los Angeles. And I remember them coming into the engineering team, half a dozen of us, and saying, hey, would any of you guys like to go to California? Now, we were early 20s, So our bags were packed that night. But then I came up to a conference, walked onto the Cisco booth, started looking at the product, made a few snarky comments about how the UI looked, and that led to a conversation, which led to a conversation, and I joined the company as a software engineer in 94, primarily in the, layer 2 switching realm. That was sort of how I got over here and got into Cisco.
Cisco, up until this point, was known as a router company, but the acquisition of Crescendo Communications in 1993 gave Cisco the opportunity to start competing in the switching marketplace with what they named the Catalyst product family.
Crescendo grew into being the Catalyst series of switches, which over the next 5 years was probably or arguably the most significant product in the industry, and certainly the most significant by revenue.
The Crescendo acquisition also brought along their ISL or inter-switch link technology, which was their own proprietary VLAN solution. While they had thought about licensing this out to other manufacturers, they recognized that what was really needed was a new open standard to make VLAN interoperability a reality.
We'd been looking at the use cases and the value around a VLAN solution on the iOS side, right? And we'd said, hey, is there, what's the current state of the art? And we'd stumbled upon a standard called 802.10, which was really about injecting a security identifier there. And we said, look, why don't we use that?
802.10? The most fundamental challenge for a VLAN standard was ensuring that all switches on a network, regardless of manufacturer, would make the same forwarding decisions. Every switch needed to understand which VLAN each frame belonged to. And that's where Cisco identified a potential solution with 802.10. The 802.10 standard, finalized in 1992, provided a solution for security of data on both local and metropolitan area networks. As local networks expanded across campuses and cities, operators needed a way to ensure the integrity and confidentiality of transmitted data, and Cisco's idea was to adapt 802.10 to support VLANs. For Cisco, this would give them a massive advantage, as their routers already supported 802.10, meaning it would enable them to support the standard far sooner than any of their competition.
There was half a dozen switching vendors all looking to take the lead in terms of virtual LAN technology. So, as soon as the standards are out, we are standards compliant. There's huge marketing value to that because the customer base were looking to purchase. And again, there was a lot of, this was 95, 96. I mean, broader things were going on, telecom, deregulate, there was a lot of hype around networking. So there was a lot of money to be made by the vendors. And this would have been something that they'd all wanted to make sure that they're not too far behind on. The reality is, and as I recall, we went to the IEEE and we went to the 802.10 group and we said, hey, listen, we think there's a pretty big play here and this could become the VLAN standards, right? The working group at that point said, no, we've used that for security. We've got different mechanisms and stuff like this.
The sticking point was that the chair of the 802.10 working group, Russ Housley, didn't want to remove encryption from 802.10, which was meant to be a security standard. But encryption didn't make sense for VLANs, as it would require expensive cryptographic hardware in every switch, which is something that neither manufacturers nor customers needed.
So the notion of we need encryption at layer 2, that's nonsense. Whereas, if those guys had had the vision, right, we'd have been talking about them today. And that would have been a very, very significant standard in the industry. Now that's just my opinion, but I'm right.
With Cisco and the 802.10 group unable to reach an agreement, the path forward for the VLAN standard was still unclear. This disagreement ultimately led the group to miss the deadline to submit a PAR or Project Authorization Request to IEEE, pushing the standard out even further. But check this out. We found a stash of documents about an unofficial meeting that took place on January 24th of 1996 at a Sheraton hotel in Milpitas, California. And it sounds like this meeting was trying to figure out how to move forward on VLANs as they were still grappling with the most basic details. There were over 50 attendees at this meeting, and there were presentations from 3Com, Cisco, as well as John Wakerly from Alantec. And before moving on, this won't take long, but we just want to give a special shout out to all of our Patreon supporters. You guys are all absolutely incredible. Because of your support, we're able to do deep research like this and keep the channel focused on content that you actually want to see. We get dozens of sponsorship emails every week from gaming chairs, VR headsets, smart glasses, personal injury attorneys, basically everything. But thanks to your support through subs, views, merch, and Patreon, we don't have to interrupt our videos with ads for things that have nothing to do with our channel. We can stay true to our mission of preserving and exploring this technology without having to pretend we're suddenly passionate about ergonomic office furniture. So seriously, thank you all so much for your support, and we'll get right back into it. The most basic problem they needed to tackle was how switches would identify which VLAN a given frame belonged to, and there were two main approaches. The first was that frames could be tagged with an identifier. Similar to the 802.10 method, switches would add a header to the frame containing a VLAN identifier. But because the frame has been modified, this requires recalculating the frame's CRC, which is a mathematical fingerprint calculated across the entire frame and enables receiving devices to check for data corruption. But this technique had a potential issue. At the meeting, Wakerly presented about a scenario where the contents of the frame could be corrupted, or what they called clobbered, when the switch inserted the VLAN headers, leaving the new recalculated CRC useless. Wakerly formulated a workaround for this issue by leaving the original frame unmodified and appending VLAN tags in a way that kept the original CRC intact and valid. This meant that even if the packet was corrupted or clobbered, the original CRC would still work for error detection. And another earlier approach to VLANs didn't involve changing the traffic on the network at all. David Cheriton published a draft about a Virtual LAN Management Protocol, or VLMP, earlier in 1995. In this method, instead of tagging frames, switches would maintain tables that mapped each device's MAC address to a specific VLAN. When a switch received a frame, it would look up which VLAN that MAC address belonged to and only forward the frame to ports connected to that same VLAN. The switches would share these MAC to VLAN mappings with each other using a management protocol, keeping tables synchronized across all of the connected switches. As devices joined the network or moved around, switches would update their tables and propagate the changes. And this approach had appeal. It worked with existing network cards and didn't require any frame modifications or CRC recalculations. But it did have serious drawbacks.
Which is kind of like pulling routing technology down to layer 2, right? But, if the solution was to say take, an ARP table or a list of MAC addresses and shunt them between switches and say these MACs are in this VLAN, that becomes highly dynamic. You're inviting, sort of synchronization challenges and how current is your update.
So despite these ideas and many other proposals, the group was still at an impasse on how to move forward. But then we read this document. Late on the 26th, the last day of the meeting in Milpitas, an engineer from DEC proposed a solution. Anil Rajsingani presented an alternative, which is to split the original frame between the MAC source address and the type/link field, and insert a new ether type value and a 2-byte VLAN ID. This has the advantages of minimal frame expansion, preservation of a valid frame format, and it is conceptually very simple. The CRC would be recalculated. And this solution ended up making history, as at the next plenary meeting on March 14th in La Jolla, California, the members finally agreed on this new frame format. The IEEE members voted, with 30 members advancing the proposal and only one nay. A project authorization request was then drafted and sent to IEEE, officially creating the 802.1q VLAN Working Group. And this was it, the birth of VLANs as we know them today. Over the next 2 years, the group would hash out all of the details to turn VLANs into a complex, feature-rich standard. And it wasn't just Ethernet. VLANs needed to support both Token Ring and FDDI as well, the other 802 LAN technologies at the time, creating 3 different tags defined in the standard. And in order to be compatible with existing LANs, the group came up with the concept of trunk and access ports. Trunk ports transmit and receive VLAN tag traffic, whereas access ports deal with untagged traffic, like with a VLAN unaware switch. And while they didn't use the VLAN management protocol we described earlier, the group did include one called GVRP. The new protocol allowed switches to propagate VLAN information to other switches, so that a new VLAN could be created on one switch and then dynamically added on other switches. With these details and many others finally worked out, 802.1q was published on December 8, 1998. The final standard was nearly 200 pages long, the culmination of over a decade's worth of work. Interoperable VLANs were here, and 802.1q support could finally proliferate through the marketplace. And it wasn't the end for VLANs. Many new amendments and related standards have been published since 1998, and several are in active development as of this video's publication. One of the highlights was the 802.1ad amendment published in 2006 that allows multiple VLAN tags to be inserted into an Ethernet frame, enabling technologies like Metro Ethernet. And GVRP has been replaced with MVRP, simplifying VLAN management even further. This journey to discover the origin of VLANs was way more complex than either of us had imagined. This seemingly simple feature hid an entire world of history behind it. There were devices like the Alantec Power Hub that we had never heard of, people that had an instrumental role in the standard like Martin McNeilis, Norm Finn, Mick Seaman, John Wakerly, and so many others that we otherwise might not have ever known about. And what's remarkable is how their work became foundational for networks today. .1q VLANs are still in use today in networks of all types, from offices, data centers, phones, and even home networks. And the story doesn't end with 802.1q. The concept of creating logical separations on top of physical infrastructure proved so powerful that it spawned an entire family of technologies, like VXLAN, which extends VLANs across data centers and cloud environments, supporting millions of virtual networks instead of the original 4094 limit. Or what about MPLS, which creates virtual paths through service provider networks, enabling everything from corporate VPNs to the traffic engineering that keeps the internet running smoothly. And really, we've only scratched the surface with VLANs. So if you like this video and you want to see more like it, please subscribe to the channel and leave us a comment with your ideas. So from the brilliance of Dave Sinkowski's groundbreaking idea to the pioneering Alantec Power Hub and all of the people involved in making 802.1q a reality, the Virtual LAN has been a critical part of networks going on for 3 decades now, and it still continues to this day. Thanks for watching the Serial Port, and we'll see you next time.